everyone, and welcome to the second episode of Whispers from the Star, the official podcast of AIAC Space Club. My name is Douaa.
And I am Soukaina.
Both first-year computer science students at Mohammed VI International Academy of Civil Aviation. We hope we can have a pleasant and snug chatter. You're all welcome to join as we set forward this month's Star Whisper. So, what did the Star whisper to us this time, Soukaina?
Well, we have a special mission as Sky Tellers this month. We're assigned to cover up the night, the magic, and the mysteries of our whispering star.
It's an intriguing topic.
Indeed. Thus, we will moot about its formation, the stellar evolution, death, and remnants. But first, do you know how do stars form?
They form within cold, slowly rotating interstellar clouds of hydrogen and helium gases and dust, called molecular clouds, that contain huge masses of material enough to form several stars.
Exactly, and they also vary in size, mass, and temperature. Diameters ranging from 450 times smaller to over 1,000 times larger than that of the Sun. Masses range too from a 28 to over 50 solar masses, and surface temperature can range from 3,000 degrees Celsius to over 50,000 degrees Celsius.
Did you know that the color of a star is determined by its temperature?
As a matter of fact, no.
Stars are blue, and the coolest stars are red. The Sun, for example, has a surface temperature of 5,500 degrees Celsius, so its color appears yellow.
Then, the Sun is a cold star? Is there anything hotter than the Sun?
There are lots of places in our universe where it's much hotter than the Sun.
In connection with that, the energy produced by the stars is by nuclear fusion in their core. That will make them shine brightly for many years. And actually, the exact lifetime of a star depends very much on its size. Very large, massive stars burn their fuel much faster than smaller ones, and they might only last for a few hundred thousands of years. Smaller stars, however, will last for several billions of years because they burn their fuel in a much slower way.
Eventually, the hydrogen fuel that powers the nuclear reactions within stars will begin to run out, and they will enter the final phases of their lifetime. Over time, they will expand, cool, and change to become red giants. The path that follows beyond that depends on the mass of the star.
And small stars like our Sun will undergo a relatively peaceful and beautiful death that sees them pass through a planetary nebula phase to become a white dwarf. This white dwarf eventually cools down over time and stops growing to become a so-called black dwarf.
Wait, okay. Some of our friends might have lost our conversation thread, so let us give them some explanation. A planetary nebula is an expanding, glowing shell of hot gas that is cast off towards the end of a low-mass star's life.
And despite the name, they have nothing to do with planets. They were named so because early astronomers thought that they looked a bit like planets through a small telescope.
Stars turn into planetary nebula towards the end of the red giant phase, a point where the star becomes highly unstable and starts to pulsate.
Omitting to the white dwarf too, who is the remaining compact core of a low-mass star that has come to the end of its lifetime following a planetary nebula event. They are thought to make up roughly 6% of all known stars in the Sun's neighborhood.
Indeed, massive stars, on the other hand, will experience a most energetic and violent end, which will see their remains scattered aboard the cosmos in an enormous explosion called a supernova. Once the dust clears, the only remaining thing will be a very dense star known as a neutron star. These can often be rapidly spinning and are known as pulsars. If their star which explodes is especially large, it can even form a black hole.
Black holes are another intriguing topic. By the way, do the Twinkle Twinkle Little Star tell you something?
Isn't it a nursery rhyme?
You bet. And did you ever wonder why do stars twinkle?
It's because their light passes through Earth's thick, turbulent atmosphere to Earth's surface where we view them.
Yes, and as the starlight passes through the layers of the atmosphere, it gets refracted a little whenever it encounters air pockets of different density.
It makes the star position appear to jump or twinkle.
Right. The light coming from stars closer to our horizon twinkle more because the light is passing through a thicker portion of atmosphere than starlight coming from overhead. And if you viewed stars from above the atmosphere of Earth, say sitting aboard the Hubble Space Telescope, they would not twinkle at all.
Our star, the Sun, or Sol, which is more a poetic name than an official one, is a special celestial body. It's the center of our solar system and very important to us. Our star, the Sun, or Sol, which is more a poetic name than an official one, is a special celestial body. It's the center of our solar system and very important to us.
Our star provides us with light and heat. The heat warms us and empowers the movement of our atmosphere and ocean, and the light is used by plants to make aliments for us and to put oxygen in the atmosphere.
Other ways, however, our star is average. It's a medium-sized star of average brightness. It's considered stable, a main sequence star, and it's in the stage of its life where it's fusing hydrogen nuclears into helium and giving off energy.
And, just like any other star, our sun evolves with time. Although making this energy consumes its fuel and it will run out of it one day. But don't worry, the sun will keep shining as it is for about another 3 to 5 billions of years. By the way, Douaa, when you identified the sun as an average star, did you follow any specific classification?
In fact, yes, I did. Stars are classified by the mass, the color of visible light they give off, and their temperatures. And there are general relationship between these characteristics. Low-mass stars like our Sun, for example, have masses that range from 0.1 to 4 times that of our Sun. These stars tend towards the cool side. They shine yellow to white for most of their lives while they are fusing hydrogen to helium. Their surface temperature are about 5,000–6,000 Kelvin. In fact, yes, I did. Stars are classified by the mass, the color of visible light they give off, and their temperatures. And there are general relationship between these characteristics. Low-mass stars like our Sun, for example, have masses that range from 0.1 to 4 times that of our Sun. These stars tend towards the cool side. They shine yellow to white for most of their lives while they are fusing hydrogen to helium. Their surface temperature are about 5,000–6,000 Kelvin.
Are there any stars whom are broadly similar to the Sun then?
Many precise measurement techniques and improved observation allowed for greater precision of many details, enabling the creation of a solar analog category for stars that were particularly similar to the Sun, like the Tau Kitty single star.
Well, living on Earth might be expensive, but at least we get a free trip around the Sun every year without enrolling in a competition.
By all means, and do you know what does a star win in such a competition?
A Golden Globe Award?
A constellation prize.
Oh, we know a friend who loves constellations. I think she will enjoy today's podcast if we mention them.
Well, a constellation is a group of stars that appears to form a pattern or pictures like Orion the Great Hunter, Leo the Lion, or Taurus the Bull. They are easily recognizable patterns that help people orient themselves using the night sky, and there are 88 official constellations.
Each constellation is a collection of stars that are distributed in space in 3 dimensions. The stars in a constellation appear to be in the same plane because we are viewing them from very, very far away.
Previous token, the brightest stars are not necessarily the closest. Of the stars in Cygnus, the Swan, the faintest star is the closest, and the brightest star is the farthest.
Concerning that, what's your favorite star?
Actually Sirius, and it's the brightest one in the outer space.
Sirius belongs to Canis Major, or shall I say the Great Dog constellation.
It's clearly a fact, no doubt about it.
And do you know how are constellations named?
Names come from zodiac signs, isn't it?
No, it is quite the opposite. Most of constellations' names we know came from the ancient Middle Eastern, Greek, and Roman cultures. They identified clusters of stars as gods, goddesses, animals, and objects from their stores. and in some cases, the constellation might have had ceremonial or religious significance. In other cases, the star groupings help to mark the passage of time between planting and harvesting.
Nowadays, astronomers divided one of the constellations into 3 parts. There are 48 ancient constellations, and they are the brightest grouping of stars, and those whom are observed easily by the uneyed eye. There are also 38 modern ones, like the Peacock, Telescope, and Giraffe, who were identified by later astronomers of the 150s, 160s, and 170s, who used telescopes and who were able to observe the night sky in the southern hemisphere.
Astronomers actually consider any star within a constellation boundary to be part of that constellation, even if it's not a part of the actual picture.
Indeed, but not all of the stars are part of constellation. There are billions of them, but only a fraction make up the shapes of a stellar grouping.
Hundreds of those bright stars were given names in ancient times. These include Ilthanen of Draco the Dragon and Vega and Lyra the Leo. Many of them have multiple names, having that they have been observed by different cultures, but today stars are just names by their coordinates on the celestial sphere.
Celestial sphere is an imaginary sphere surrounding Earth, and all stars and objects in space such as constellation can be mapped relative to the poles and equator of that celestial sphere.
Their position north or south of the celestial equator, or essentially their latitude, is called declination.
East or west essentially is their longitude, east or west from Greenwich.
Well, speaking scientifically, star position is the apparent location of any given star in the sky, which seems fixed onto an arbitrary sphere centered on Earth. The location is defined by a pair of angular coordinates relative to the celestial equator, right ascension and declination. This pair based in the equatorial coordinate system.
Declination is given in degrees. Right ascension is usually given in an hour angles. This is due to the observation technique of star transits, which cause the field of view of telescope eyepieces due to the Earth's rotation. The observation techniques are topics of positional astronomy and of astrogeodesy.
Ideally, the Cartesian coordinate system alpha and delta refers to an inertial frame of reference. The third coordinate is the star's distance, which is normally used as an attribute of the individual star.
There are many factors that change star position over time. The first one is axial precession and nutation, slotted of Earth's axis with rates of 50 arcseconds and 2 arcseconds respectively per year. The second one is the aberration and parallax effects of Earth's orbit around the Sun. And the third one is the proper motion of the individual stars.
Exactly. And the first and second effects you just mentioned are considered by so-called mean places of stars, contrary to their apparent places as seen from the moving Earth. Usually, the mean places refer to a special epoch like 1950s or 20,000. The third effect has to be handled individually.
Who are interested in the compilation of several stars, declination and right ascensions, there are many star catalogs of different volume and accuracy. There are ones with the absolute and very precise coordinates of almost 100 till 300 stars, which are collected in the fundamental catalog starting with the FK Bell in 1890 up to the modern one FK6. More relative coordinates of numerous stars are collected in catalogs like the Bonner Darkham Mustang or the SAO, Smithsonian Astrophysical Observatory Star Catalog.
Well, as our podcast is heading to its end, we have one more thing ongoing: how to navigate by the stars. Before the GPS, before the compass, your main means of finding your way was to navigate by the stars. Although today's technology makes finding your way easier, it is still fun to learn how to navigate by the stars. You can fade north, south, east or west by learning a few stars and constellations, or you can simply pick out a star and follow its movements.
Well, there are actually 6 main methods to navigate by the star. The The first one is finding the star Northern Hemisphere. It actually depends on looking for Polaris North Star. Polaris is actually the brightest star in the constellation Ursa Minor, the Little Bear. It can be found in the Bear cell. The star is called Polaris because it appears within a degree of the celestial North Pole and so appears not to move in the night sky. Today, because the 7 stars of Ursa Minor looks like a small Little Dipper, most people refer to Ursa Minor as a Little Dipper instead of the Little Bear.
After that, use pointer stars to help you find the North Star. Although Polaris is visible in the northern sky at most locations north of the equator, it can be hard to spot if you don't know exactly what you're looking for. You can use stars in other constellations to point the way to Polaris.
And the most commonly used pointer stars are Merak and Douaa, the 2 stars on the edge of the Big Dipper opposite its handle. By following the stars in the direction of the Big Dipper's mouth, you can find Polaris. If you go 5 times the mark, Douaa distance away from the Douaa, you will be within 3 degrees of Polaris. If Polaris is clouded over, you still know where it is.
During the times of night when the Big Dipper is below the horizon, such as the early hours of fall, you can use another method. Find the Great Square of Pegasus, measure the distance from Alpheratz, which is visually a part of Pegasus but actually part of the constellation Andromeda, to Kaf, the star of the rightmost edge of the W-shaped constellation Cassiopeia. In line with Alpheratz and Kaf, measure another of these distances, you will be less than 3 degrees from Polaris. And, like the previous method, you do not need to see Polaris.
The second method, if you are at the Northern Hemisphere, is to find your latitude. You have first to locate Polaris. Use either of the pointer star methods to help you. Then, you have to determine the angle in degrees between Polaris position and the northern horizon. The most accurate way to do this is with a quadrant or a sextant, which lets you read the angle of its curved section. This angle measure is the same as your latitude north of the equator.
If you do not have a quadrant or a sextant, you can approximate the angle by extending your fist to the horizon, and then stack and fist hand over hand until you reach the North Star. Your extended fist is approximately 10 degrees of angle measure.
If you are in the Northern Hemisphere and you need to find the South, the first thing to do is to look for the constellation Orion. The constellation Orion, the Hunter, bears a resemblance to a bent Hoglis. The star Betigelis and Bellatrix represent its shoulders. The stars Saiph and Regal represent its knees or feet. The 3 stars in the middle, Al-Nitaq, Al-Ninam, and Mintakar, represents Orion's belt. In the northern hemisphere, Orion is visible chiefly in the winter and early spring, but can be seen late at night in the fall or before sunrise in the summer.
Find Orion's sword if you can. Look for one moderately bright, one dim, and one fuzzy star hanging from El-Nilam, the middle star in Orion's belt. This represents Orion's sword, which points to the south. By the way, Douaa, did you know that the fuzzy star is actually the Great Nebula of Orion, an interstellar nursery where new stars are being formed?
No, I didn't know that. But you know, the series will always remain my fav. I can't change it, sorry.
Too bad then. Well, the fourth method we propose is finding south when you're in the southern hemisphere. You have to look for Crux, the southern cross. While there is a star near the south celestial pole, Sigma Octantis, it is too dim to do you much good for finding south. Instead, look for the bright constellation Crux, the Southern Cross, which consists of 4 stars that form the ends of the cross's upright and crosspiece.
One more thing, the Southern Cross is so important constellation that is depicted on the flags of Australia and New Zealand. However, if not particularly large, it's only 1 degree longer than the distance between the pointer stars in the Big Dipper. That will make the pointer star, Regal, Centaurus, and Hadar so important. They keep you from looking on in the false cross, which is nearby and just a little bigger.
I cannot disagree, but all stars and constellations are actually important. Well, next, dear travelers, you have to extend the line through the long axis of the cross. The point along this line above 4.5 times the length of the long axis that is directly above south.
Great. And you know, optionally, to improve your accuracy, is to find the two pointer to the Southern Cross and drawing a line through them. Then take a line perpendicular from the middle of that and extend it to intersect the line drawn from the Southern Cross, where the intersect is directly above South. When drawing that, the two stars of the crosspiece will point you to the star Alpha Centauri, the closest star to Earth after the Sun.
And once on the celestial equator and you need to find east or west, you have to look for the constellation Orion again. And as noted before, the torso of the constellation looks something like a bent hourglass. Then look for the rightmost star in Orion's belt. This star, Mentaka, rises and sets within a degree of true east or west.
Well, and if you're anywhere in the Earth and you need to find direction by following a star position, all you need is a stalk or two stalks. You can drive them in the ground. The stalk should be about 1 yard, which is approximately 91 centimeters apart. Then, you need to pick any star you see in the night sky. You can use any star for this, although I'm pretty sure you want to pick one of the brightest stars.
Then, line the star up with the tops of both stakes, and wait for it to move out of position with the stakes. Earth's rotation from west to east causes the stars in the sky as a whole to rotate from east to west. Which way has the star moved with respect to its original position where you sighted it tells you which direction you are facing.
Then, dear friend, if the star rose, you're facing east. If the star sank, you're facing west. If the star moved to the left, you're facing north. If the star moved to the right, then you're facing south. Pretty easy.
Well, that was a lovely chatter today.
Yes, actually, I enjoyed that too.
Well, everyone, that was the end. We hope you enjoyed today's podcast all along with me and my friend. And remember, when you're in the gutter, you can always look at the stars.